Assalamualaikum. My name is Wan Ahmad Azli bin Wan Muhammad Yunus, and I will be presenting about the introduction of the project. So, firstly, for the background of the study, solar energy was selected for investigation because to its abundant and inexhaustible nature. Currently, solar energy is considered to be one of the most appealing and promising sources of renewable energy. The current technology of solar collectors is employed to gather solar radiation. There are three types of solar collectors, which are batch, flat, plate, and evacuated tube collectors. Each of them serving different way of working and also practicality. Figure shown is the flat plate collector, which is used in this project. Then moving on for the problem statement, the energy demand for commercial buildings such as restaurants varies depending on factors like size, operating hours, and equipment efficiency. For instance, modern style restaurants may require higher energy use as compared to traditional restaurants. The solar collector efficiency and market challenges should also be taken into consideration when conducting this project. This project focuses on the use of solar water heaters in restaurants in Kuala Lumpur, and the aim is to develop an efficient solar water heater system that can reduce the dependence on coal generated electricity by utilizing solar energy as the renewable source. For the scope of work in this project, first is to identifying the initial requirements. Next is to outline the project objectives, creating a Gantt chart and establishing project milestones. Then we can develop the sketches and initial concept designs of the solar water heater system. Then we produce the technical drawings of the design solar panel. And lastly is to discuss the sustainability impacts, including environmental, economic, and social aspects. And lastly, for the objectives of this project is to design a solar water heater for a restaurant with required operating temperature at 85 degrees Celsius. Second objective is to satisfy the maximum capacity of 3 meter cube of water to be supplied by the solar water heater. And lastly is to design the solar panel based on 7 hours of sunlight.
So here is the list of the literature review that involved in our project. First one is the type of solar water system. In the first bullet point, we studied about the active systems which use mild and indirect circulation. And the second bullet point, we study about the passive systems. The, for the second point, we use the literature to understand about the solar water collector which will be used in our restaurants in Kuala Lumpur. And last literature is about the performance and efficiency of our selected design. So here is the climate considerations that we have taken into account when doing our project. The first one is practicality. It will be based on the location and the climate, which is in Kuala Lumpur, it's hot and humid. And the second one is climate factor. Climate factor will consider about the average temperatures during the day and night. It will also take into account the rainfall and the sun in a year. And the last one is economical. We although efficient, higher we will also consider the cost of the system itself as we will try to not over budget this project. So after we have done the preliminary studies, this is our conceptual design. So we have decided to choose an active solar water heating system with direct circulation and using flat plate collector. So in this slide, uh, it will outline the function, the design, and benefits of every parts that we have taken into our project. The first one is flat plate solar collector, which is the function is to capture solar energy. Second one is storage tank, which is used to store heated water, ensuring availability during evening or cloudy days. The third one is heat exchanger. This is the part which is inside the tank, and it will transfer the heat from collectors to water, made of and it is made of high thermal conductivity and corrosion resistant material. The fourth one is control system. This is the system that we will use to ensure the smooth of our project design. It includes controllers, sensors, and user interface. And the last one is connecting the pipe itself. It is to connect every part and transfer the water itself.
Good afternoon, everyone. Today, I'll present our study on designing a solar water heating system for a restaurant in Kuala Lumpur. The system uses flat plate solar collectors to heat water to 85 degrees, supplying up to 3 meters cubic daily. The key parameters for our design include a water inlet temperature of 25 degrees Celsius, an outlet temperature of 85 degrees Celsius, a 3000 liter storage tank, an average solar irradiance of 5 kilowatt hour per meter square per day. With an ambient temperature around 30 degrees Celsius, a transmittance of 0.9, an absorption of 0.95, and a design factor of 1.2, and a heat loss coefficient of 6 watt per meter squared. We selected an active system for its efficiency and reliability, ensuring it meets the restaurant hot water needs while supporting the environmental sustainability goals. Our solar water heating system consists of a solar collector, heat exchanger, storage tank, and control system. The design sketches illustrate how the system captures sunlight, converts it into heat, circulates the heated fluid, and stores in the hot water. This setup ensures an efficient and sustainable hot water supply, offering a reliable and eco-friendly solution for meeting the restaurant's hot water needs. To determine the energy requirement for heating 3 meter cubic of water from 25 degrees Celsius to 85 degrees Celsius, we use the formula Q equals to rho VCP theta T. Substituting the values Q equals to 1000 kg per meter cubic, multiply by 3 meter cubic, and multiply by 4200 joule per kilogram Celsius, and multiply it by the changes of the temperature, we get the Q equals to 756 millijoule. For the collector area calculation, given an average solar irradiation in Kuala Lumpur of 5000 watt-hour per meter squared per day and expected 7 sunshine hours, the energy input would be 5.25 millijoule per meter squared. With an efficiency of 50%, the effective energy output would be 2.625 millijoule per meter squared. Thus, the required area will be multiplied and divided by 756 over 2.625, we get the 288 meters squared, the total area. And divide it by 4 meters squared, we will get 72 solar panels are needed for each to get the required energy. Here is the design of the flat plate solar collector, which has an area of 4 meters squared. This design is optimized to capture and convert sunlight into the necessary amount of energy to meet the system requirement. By utilizing this collector, we ensure an efficient and effective means of harnessing solar energy for our hot water supply. Here is the design of the storage tank with heat exchanger, featuring a capacity of 3 meter cube. This setup is engineered to efficiently store the heated water and facilitate optimal heat exchange. By integrating these components, the system is capable of meeting the required energy needs, ensuring a consistent and effective hot water supply of the restaurant. Thank you.
This slide shows the Gantt chart for the project. So these are all the tasks that we have conducted in order to complete this project, and it also shows the time that each of these tasks are completed. And the key milestones, as can be seen from the site, is the identification of the project need, the conceptual design and selection criteria, the 3D model projection, and lastly is the submission of the report and also the presentation.
Environmental impacts. It utilizes renewable solar energy, reducing reliance on conventional sources, lowering carbon emissions, and promoting sustainable energy transition. It also encourages sustainable practices by reducing energy consumption and waste through durable and efficient solar water heating systems. It sets an example for the restaurant industry to adopt eco-friendly technologies. It also contributes to sustainable urban environment in Kuala Lumpur, inspiring business partners and residents to adopt renewable energy, fostering sustainable and resilient communities. It also reduces the restaurant's climate impact by lowering greenhouse gas emissions from traditional fossil fuel based water heating methods. represents a technological leap, showcasing renewable energy solutions and potentially influencing industry standards and infrastructure. For the cost analysis, number one, energy consumption before solar installation. We assume that the restaurant's monthly water heating cost using conventional methods is RM 3,500. And then for the solar water heating system specifications, the solar water heating system has initial cost of 30,000 ringgit, including installation fees. The system is expected to last 20 years. For government incentives and rebates, we assume the restaurant qualifies for a 30% government rebate on the total system cost, and the effective initial cost after the rebate is RM 21,000. For the solar system performance, the water heating system is estimated to reduce water heating energy consumption by 50%. And for the solar energy generation, KL receives an average of 7 hours of sunlight per day. So, and the solar water heating system also has an efficiency of 50%. For the cost analysis, this is the calculations. So for annual savings, it's energy savings that equals energy consumption before times the reduction percentage of energy savings. So it's RM 3,500 times 0.7, and then we get RM 2,450. For the effective initial cost after rebate, its effective initial cost equals to initial cost times 1 minus the rebate percentage of initial cost. That is RM 30,000 times 1 minus zero point 0.3, and you get RM 21,000. And for the annual return on investment (ROI), so our annual ROI is effective initial, equivalent to RM 2,450 times 100%, and then we times that. After that, we get 11.67%. For the monthly savings, it's annual savings divided by 12 months. So RM 2,450 divided by 12, and you get RM 204.1 per month. So for the monthly energy cost after solar installation, it would be energy consumption before minus the monthly savings. So that would be RM 3,500 minus RM 204.7, equivalent to RM 3,295.83. Some points to note: the restaurant should save around RM 2,450 per year on water heating after installing the solar system. And government rebates and long term savings offer a good return on investment despite the high initial costs. And the restaurant's monthly energy bills will also drop, providing environmental and financial benefits over time. For the cost payback period, our effective initial cost after rebate is 21,000 ringgit, and our annual savings is 2,450 ringgit. So for the annual payback amount, it's effective initial cost divided by annual savings, and you get a total of rounded off to 9 years. So for the cumulative payback period, it's effective initial cost over annual savings times 12 months, and you'll get a total of 96 months. The payback is estimated at 9 years and 96 months cumulatively. Based on the 2,450 ringgit annual savings, the restaurant may return its solar water heating system cost in 9 years. After this, the restaurant's lower energy costs will also help save them in long term. And remember that the area incentives, energy use, and solar water heating system details can affect the payback period, but future energy rate and maintenance cost changes may also affect the payback period. Regarding sustainability, for the environmental impacts, it reduces the restaurant's carbon footprint by using solar energy. It also decreases reliance on traditional energy sources, lowering greenhouse gas emissions. It also aligns with national and local climate change initiatives, promoting an eco conscious business model. For economic sustainability, it provides long term savings through reduced energy costs despite high initial investment, benefits from government rebates and incentives, making solar energy financially feasible. It also offers resilience against future energy price fluctuations, providing financial security. For social impact, it enhances the restaurant's reputation and standing in the community by using renewable energy. It also attracts environmentally conscious customers, boosting the restaurant's image as a socially responsible business. Finally, it supports local social and economic development by creating jobs in the green technology sector. For the conclusions part, solar energy is a feasible alternative given Malaysia's climate with nearly 7 hours of daily sunlight. Solar electricity can be utilized for hot water production in Kuala Lumpur's 350 food establishments. The conceptual design of the solar water heater, the key components are its solar collector, storage tank, pump, control and instrumentation, connecting pipe, supporting stand, and heat exchanger storage tank. The design considerations are climatic suitability, practicality, system reliability, and maintenance. The SWH system is designed to hold 3,000 liters of water with 72 solar panels, providing a total absorber area of 288 square meters. Critical factors for the design justification include cost, efficiency, maintenance, quality, reliability, and ease of installation. For the selection and evaluation, four SWH systems were considered, which is the vacuum tube, passive, drain down, and active. The active solar water heating system with the flat plate collectors was chosen based on the cost, efficiency, and reliability. For the system aligns with multiple sustainable development goals, which are SDG 7, which is affordable and clean energy through solar electricity, SDG 13, climate action by reducing reliance on fossil fuels, SDG 12, responsible consumption and production via sustainable restaurant practices, SDG 9, industry, innovation, and infrastructure through advanced technology applications, and SDG 11, sustainable cities and communities by inspiring similar solutions in other cities. For the economic viability, it is projected a 20-year lifespan with an initial cost of 30,000 ringgit. Now, 20-year lifespan, yeah, with an initial cost of 30,000 ringgit. Annual savings of RM 2450, achieving payback period after 9 years. The system also proves economically viable with a modest profit margin.